So I'm going to move straight into the first talk, which is about automatic synchronization of unsynchronized digital recordings, which is a bit of a handful. So I'll outline the problem, talk about how we're talking about post-production synchronization here, so there's no attempt at real-time synchronization. I'm going to describe a work in progress automatic solution for this, some of the complications, and then where I think this system is going in the future. In many respects, this talk is like a follow-on talk from one that I gave in 2010 about this particular subject. And that talk, which is referenced on the slide, is available on the line. And if you're interested in the nitty-gritty of this particular problem and why it's an issue and all that, I'd encourage you to look that talk up and view the video, which is still accessible. Just Google it. But for those who weren't there or whatever, I've pinched a diagram out of that talk, which just illustrates the problem. So really what we're talking about here is a situation where you've got multiple digital recorders spaced around an auditorium doing recordings, but for one reason or another their clocks aren't linked to each other. Now, in the professional area, when you've got, the professionals basically run a single clock cycle or a single clock generator in their room. They distribute that clock to all of the devices. All the devices can plug that clock into them and it all runs synchronously and everyone keeps in time and everything's happy. With consumer level devices, they don't have those clock inputs, so you can't synchronize them to external things even if you want to. And so what happens is that each of their clocks runs at a slightly different time, and you can imagine, as per the diagram up there with the little dots, that a sample taken on one recorder is not exactly aligned with the sample on another recorder. So over time, they drift out. And so I've exaggerated in the diagram here, but in the top, for the device 1 in that diagram, we have 5 samples in the 4 time units. The second one we have 4. The third one we have 4, but you notice how they're not actually clock aligned. And then down the bottom we've got one that's really running great guns, and that's doing 6 samples in 4 real-time units. So the problem is that when you come to do post-production on this, if you sort of align all of these sources up at the same time in time at the start, 10 minutes later they're actually out by a significant margin. And so if you sort of set them all up in a timeline and hit play, everything's in sync for the first 2 or 3 minutes. And then after 2 or 3 minutes, your brain starts to hear something weird, which is like the thing's drifting out of time slightly. You can't pick it at that point, but they're drifting out of time. As time goes on, it becomes more and more obvious. And in most cases, by 30 minutes, you can actually hear an echo or a slap as the multiple sources have now drifted so far that your ear can actually hear the different distinct sources, one coming slightly after another. So if you've got a long event or something that you're recording, this is kind of annoying because you can't just say, okay, I'll cut this bit here and realign and cut this bit here and realign. If you've got 3 or 4 sources, that's going to be a major pain. So what we're trying to do in post-production, so you've got all these recordings, what you're trying to effectively do is have all the samples from all the devices line up nicely. And the insight that the 2010 talk talked about was that, in essence, what you're actually doing here is a straight resample. So instead of having to reinvent the wheel, you can actually use things like libresample to resample in the diagram devices 2, 3, and 4 so that the new recordings or the synchronized recordings have all their samples lined up and they're all happening at the same time notionally. And we can use standard resampling programs to do this, and people like Eric, who wrote libresample, have spent an awful lot of time doing this at very high quality. So the actual mathematics of the problem is basically solved. The question comes, how do you tell the resampler what it has to do? Because this is not a standard sort of use case for a resampler. You know, a resampler says, I want to go from 48K to 44.1K, or I want to go from 96 to 48, or whatever. And that's what all the tools are set up to do. Here, you might be trying to do from 44.1011 to 44.1. Coming up with those ratios can be tricky, and in 2010 I was talking about how I did this manually by identifying points in all the streams, working out what sample numbers they were, and feed that into a program that did all the hard maths. But finding those points is tricky. So I've been looking for easy ways of automating that part of the process. So that's a roundabout way of getting back to what I'm talking about now. So I wrote a program many years ago called Audio Sync, which started out as a synchronizer to deal with a bug in my DV camera, whereby its audio clock was not in any way related to its video clock. And so you would record a long sequence, and instead of you'd record it for a certain number of seconds, and you would say expect 10,000 audio samples, but in actual fact it had done 10,010 or something. The clocks were unrelated. Very unusual. Most of the DV cameras at least have lock, but this one didn't. So I wrote this thing to automate the process of resynchronizing the audio to the video so I could actually do sensible things with, and it's grown several features since then. And so because I already had a lot of the maths and process stuff worked out for that program, I've just used that again to do the test bed for this little solution. I should emphasize that this applies to audio only. It's not an attempt to synchronize video. Video is hard because you basically can't interpolate it. The audio thing works because it's a series of samples. It's basically a time series of data, and the mathematics of resampling time series data is very well thought out, and you can do it very well. Video you can't, because it's a discrete sample of a video field, and you can't. It's not possible to interpolate between two frames to do this sort of thing. So this solution is strictly for audio. That's fine for me because generally speaking I'm using one camera for this sort of stuff. So I can have one camera. That kind of defines the master time, and then all the audio is synced to that video camera or to that video. So the way that this automatic solution works sort of goes back to the days of film, where you had the clapper boards. And so the idea is to generate a marker in all the audio tracks, hopefully one that's also linked to the video, that you do and you assume that all of those audio tracks are seeing the same marker at the same time. So it gives you a reference point to say, right, when this marker happened in this sample and in this one and this one, they were actually at the same time. And so the idea is that I generate a marker at the start and a marker at the end. So I've got two. I basically bind the two streams. Yeah, question at the back.
I can see that working well for a situation in which all your cameras are relatively close to the source of that cut sound. But in situations where you might have a close-up camera and then a background camera, one at the back of the hall, one at the front, do you have the option of being able to say this marker is this time delay away because of the speed of sound?
Okay, so for the benefit of the recording, the question's about basically the finite speed of sound, and if your microphones or whatever it is that you're using to record your audio, be they cameras or microphones, if they're spaced far away from the generator of the sound, then the speed of sound means that they don't actually get the sound simultaneously, and other allowances for that. And I will defer to the later part of the talk about that. The short answer is not yet. So the idea being we generate these markers, and then I have Audio Sync, the program, find these markers, and it basically can say, right, so in this stream, that marker is at sample X, in this stream, the first one's at Y, and then you find the ones at the end as well, and that gives you a bound on what resampling has to be done to make the second stream synchronized with the first one. And obviously this is a lot quicker than having to go into a waveform editor, find an event that you can distinctly see in both data streams, find out what sample number it is, and use that to do the resampling. So the complications, I mentioned one before, video can't easily be resampled, which means that it is an audio-only solution. The second problem is that at the moment, what I'm using as my marker is 2 blocks of wood being banged together. It produces a very nice peak, which is great because you can set things up to find that fairly easily. However, what I have found in the context of the recordings that I developed this for, which were interview type to camera pieces, is that the person doing the interviewing is fine, but the person who's being interviewed, they tend to have a nasty habit of like laughing really loudly right at the end of the take, or knocking something over as they stand up before you've actually stopped the recording, which means that you get your clap in the recording, but you also get this really loud thing that looks remarkably like a clap that comes sometime after it. And of course, the software sees that rather than the one you really want, and it can throw things out. The other complication, which I haven't mentioned in the slides, is the issue that if you've got distributed microphones, which I didn't have when for the specific purpose I was running this with, you have different microphones at different places in the room, and your clap that you do at the front will arrive sometime later at the rear microphones and whatever. So that's another problem. So the future plans for this system, I want to try and come up with a better or more robust marker detector that can take account of the poor behaviour of clients and whatever when they knock things over or clap or laugh or whatever, so that I don't have to like trim the audio before I feed it in here or whatever. Related to that, I'm trying to come up with a better marker signal rather than just a clap, which will involve some electronics or some software of some description. But if I can come up with a marker which is more distinct, like a tone burst or something like that, it pretty much guarantees that the detection software is not going to get confused by people laughing and things after the fact. And then related to that is to come up with a simple way of distributing this generated marker so that I can have a small transducer next to remote microphones and hit a button at the control point, have it distributed via wires to all the microphone points. The microphones all pick it up pretty much simultaneously. We can ignore the speed of light for this. And it solves the distributed problem. This is all work in progress. It's plans that I have. I haven't implemented it yet. But hopefully, if all that can come to pass, what we'll end up with is a relatively cheap way of doing this synchronisation for cases where you can't afford cameras with clock outputs and don't have audio recorders which have clock outputs. Yeah, question?
One fallback there might be to look at the spectrum analysis of that marker point on one, so you find the first marker point and you say, okay, that sounds like this, and it has the same spectrum on this other one. So when I get to the end of the recording, I'm expecting a similar sort of sound, frequency-wise.
Yeah, so again, benefit of the recording. The comment was that you could actually look at spectral signature of the first received marker and then say that the one at the end is going to look something like that, and so you look for something like that towards the end. And yes, that could well be made to work so long as one can guarantee that the two are actually sounding similar enough.
You'd have a bit of a fudge factor there, but it's going to be quite different.
Yes.
A laughter or
yeah,
a door slam or something.
Yeah, fudge factors needed. Agreed, yes. That's right. And I think that what's probably going to be necessary as well is something a little bit more robust than my 2 planks of wood, because even to the ear I can hear that unless I really do get them, take care to get them exactly the same both times, there is a significant audible difference between different claps. And so that may require some sort of a jig to somehow guarantee a more reliable, more reproducible sound. Did you have a question?
Yes. What you're saying, I was saying you need a professional clapper probably for that.
And actually, what you really need is audio and video interfaces with clock I/O.
The comment I was considering is the idea that you said you would like to electronically distribute the signal to be generated at the microphone. And would that actually be necessary, or if you actually generate it as an audio signal and actually microphones will register those based on the distance they're at, which is actually good information, rather than electronically, which means they're not in sync with what was recorded before. I just wondered.
Yeah, so again, the question is whether or not you could avoid the distribution and simply note at record time how far the microphones were apart from each other and therefore compensate in software. Short answer is yes, you could do that. The problem is that in many cases, you're going to find it difficult to generate a reference clapper in one location which is going to be loud enough to be registered at an appropriate level in microphones that are distant, especially if there are other people in the room and you're not wearing headphones or earplugs, right? So yeah, the idea of the distributed system is that the thing can actually be really, really soft. You can do it just before an event starts, so you've got audience in the room and they won't ever hear it. Whereas if you were relying just on the acoustic sound travelling, whilst the software could certainly be made to, be trivially modified to compensate for that distance, I'm not sure that the audience would appreciate something that loud just before an event is due to start. But in some circumstances it might be appropriate, but as a general solution, it's probably not the best approach. But yeah, certainly the software itself could be fairly trivially changed to say, this recorder was X meters away from the reference and therefore it can compensate for that. So the final slide is just a reference point to the slides from the 2010 talk, and also the website that you can pick up the current version of AudioSync from. And I've just noticed there's meant to be a little twiddle character in front of J. Woithe in that URL that for some reason hasn't shown up, and my email address is there. And that is it for this one. Yeah.
Just another comment still. I can't avoid thinking about this problem when I hear about it. If there is a problem with misidentifying the noise in the end and taking it, you could decide to go for a door knob process where you know that two of them actually very precisely timed and says, well, we can make a mistake on one. It's unlikely I get two or three in a row precisely right, and that may be more reliable. Redundancy effectively in there.
Yeah. When I do this, I've actually been doing two, but the software currently only looks for the first one at the start and the last one at the end, because the other thing about this is it had to be done in a big hurry. I had about 2 days to hack this together or something. So yeah, it is by nature at the moment, it's a very simple system and there are many ways of improving it. And yeah, the redundancy thing, and that gets back to the idea of the spectral signature as well, that if you do multiple ones, yeah, if you can detect the multiple ones, yeah, it's unlikely you'd get two like that in quick succession, that's for sure. Yes?
Have you considered looking at how film and television do multiple camera syncs?
Yeah, they use global clock. So they distribute a clock signal to the cameras have a word clock input, and they synchronise with the house clock.
With television, but what about film?
Film do the same. They have a set wide clock, and AV, like film and audio, all lock to that one global clock. They've usually got a very high-end clock generator to make a very reliable jitter-free clock signal that's then distributed.
Solution.
Sorry? That's right, exactly. If you can afford $20,000 cameras and things, then yes, it's a solution. But again, whilst I've got good audio interfaces, I cannot afford the video cameras that go with it. So I've got to do something else. Yes, probably final question.
One idea that I find myself wondering with your story of a camera with clock drift is that may not be linear across time. It may actually be speeding up or slowing down as it heats up or whatever. So once you've got your initial individual stretch for each audio file worked out, you may be able to then go through, periodically sample and say, okay, does the audio here sound similar to the audio there in terms of frequency spectrum, or even just looking at waves. Subtracting two wave files will give you a fairly obvious phase patterns if they're starting to creep out, and at that point you may be able to actually say, we're going a bit fast on this one, mark that one to be individually slowed down, and so forth.
Yeah. So again, for the recording, the comment is just that this is assuming that the clock rates of the individual devices are actually consistent from the start to the end, and it doesn't take into account the fact that clocks can speed up and slow down as the crystals heat and cool, and that there are perhaps ways of doing subtraction tests and spectral tests in the middle to see if this has happened and to perhaps compensate for that. Yes. In my experience with the devices that I've been using, once the device has reached operating temperature, and I always turn the stuff on about 10 minutes before I'm due to start, I have not found that the clocks are drifting significantly over like an 8-hour recording period. It is certainly a potential problem. And certainly there are devices out there that I think would be more prone to it than the stuff that I'm using. But it's a problem that I haven't personally had to deal with. But yes, it is certainly something that, especially with cheaper sound cards and things that might be in an environment where the temperature is fluctuating a lot, it is certainly something that may have to be looked at and compensated for sure. But certainly the first order problem is getting the actual time, the overall sampling rate reliable. And I have done a few tests on that, looking at intermediate sync points and things and checking the resulting frequencies along the time. And yeah, for the stuff I'm using, it's not an issue. But yeah, certainly some people may well have that problem occurring on top of the unlocked clock problem.